Hey everyone, today I'm super excited to bring you a brand new video on building NestJS microservices using tRPC as our transport layer. Now you may recall us using tRPC in past videos to connect a NestJS backend to a Next.js UI, and in that previous video we saw a number of benefits of utilizing this tRPC, and that includes having this end-to-end type-safe solution for our application where we have a single source of truth for our actual routes and schemas, so that whenever we make a change to a given schema in our backend, the front end types are automatically updated in real time, and it ensures we always have our code in a type safe state at all times. Now we can bring the same benefits of using tRPC on the client side to a microservices environment in NestJS. So in this example lecture, we're going to build two NestJS microservices sitting inside of the same Turbo repo, and we're going to have them actually communicate with one another over tRPC and leverage a shared tRPC library here with our common types, which ensures we only have a single source of truth for all of our schemas, and our NestJS microservices have this end-to-end type safety. So I'm super excited to jump in and get started. You're going to learn so much in this lecture. Let's go ahead and jump right in, and I'll see you there. Now, before we jump into the video, I want to let you know about my membership website. Will I leave a link below? Signing up for this membership website gives you access to hundreds of hours of exclusive developer content in the form of these extra lectures where you can learn concepts like multi-tenancy in NestJS, graceful termination in Node.js, and a bunch of other useful lectures to help you grow and expand your skill set as a full stack developer. Additionally, your membership will give you access to all 4 of my best-selling Udemy courses, so be sure to check out the site if you'd like to learn more. And if you'd like to learn more about tRPC after watching this lecture, we have a full-on project here where we build a full-stack to-do app with tRPC, including a Next.js UI and a React Native mobile app. So you can learn tRPC real-world production application. So thanks so much for checking out the site, and let's go ahead and jump right into the lecture. So let's go ahead and get started. We're going to use npm dlx create turbo at latest to go ahead and create a new Turbo repo in the workspace that you want. In my case, I'll go ahead and simply call it NestJS tRPC Microservices. Feel free to call it whatever you'd like. And let's use npm to take advantage of its fast installation speed and the ability to set up a npm workspace. All right, so our Turbo repo has been created. Let's go ahead and cd into its directory and open up our code editor. This is our starting Turbo repo where we have our applications defined inside of the apps folder and our reusable libraries inside of packages. Let's go ahead and start off by cleaning things up. We can actually remove the 2 starting applications here, which are some Next.js apps that we're not going to use. And we can also go ahead and remove our packages, so we have a clean, empty slate. Now with this out of the way, we can actually generate the NestJS microservices inside of apps. So since these are separate microservices, they're going to be separate Nest.js applications inside of the apps folder. And we can generate these applications using the Nest CLI. So let's do that by cding into the apps folder and make sure we use the Nest CLI, which you can grab with npm install at nestjs/CLI at latest. So go ahead and grab this and make sure you also install it with the -g flag to install it globally in your system. Once you have it available, we can then go ahead and use it using nest new, and I'll call this first service items. So we're going to have an items service. So go ahead and generate this with npm and let it create. So now we have the first service. Let's go ahead and simply rerun the same command, except now call this one payments. So we're going to have a payment service as well. And we'll use npm here, so go ahead and generate the second app now. Now notice it was much faster the second time around thanks to our npm dependency caching. So now we have these 2 Nest.js applications. Make sure we cd into each one. So start off with items and make sure we remove recursively the git folder inside of here, as well as the generated node modules. So do that in both of these services because we know that our monorepo is going to be handling git and node modules. So With these removed, we can rerun p-npm install at the root of our workspace. And again, this is already a p-npm workspace defined in all apps and packages. So that means, of course, the package JSON for any application we define in apps or packages will be used to install dependencies when we run that p-npm install command. And that's going to ensure we have our NestJS dependencies available. So now we can see we have both of these NestJS applications available, which is excellent. Next thing we want to do is update the package JSON script to change the start dev command. So this is the command we use to start our NestJS development server up. Well, by default, this is start dev. Let's turn this into the dev command so that it hooks into the tRPC dev command that we have defined at our root turbo.json as a task that we can run for each app. So we know in tRPC these tasks here simply execute the package JSON script for the respective service. So we want to make sure we have that dev command available to start the Nest server. Let's do the same thing for payments as well. So now we have dev updated for both. The last thing I want to do is go ahead and in our payment service, let's update our main TS file. So we can see here, this is where we bootstrap our NestJS application by bringing in the root app module, and then we bind HTTP traffic onto it on the port. Now this is going to be the same in both services currently. So we're binding our HTTP server to port 3000 in both, which of course will cause a conflict. So in payments, let's update the default port to 3001 so that we can run both of our servers in parallel. So with this small change in place, we should now be able to run both of these Nest development servers with our single turbo dev command. Let's go ahead and try this by running turbo dev at the root of the application. You can see here that it actually has started up both our applications, which is excellent. Both Nest apps are now running. Next up, let's go ahead and define some basic routes and business logic inside of our app so that we can insert some basic data, and then we'll set up our tRPC connection between the services to be able to fetch data between one another. Let's go ahead and continue on doing this next. So we're going to start off with our payment service by exposing a new payments controller and service that will allow us to associate and create a new payment, and then we can reference that payment later on when we make calls to the item service. And the item service in turn will be reaching out to payments through tRPC with the associated ID to fetch that payment. So to begin, we need an entry point into payments simply over HTTP that we can hit through Postman to actually create some new payments. So let's get started with this. To begin, we can remove the default generated app files, the app controller and app service, and then make sure we also clean up the root app module. And now let's use the Nest CLI to generate these new modules for us so we can cd into apps payments. So in the payments directory, we'll use the Nest CLI to first generate the payments module. And notice that'll also update our root app module to import it and create a directory for payments. So let's go ahead and rerun it to also generate the controller, which will accept our HTTP traffic. And we can run this without a test. So that'll create the new controller and add it to the payments module. And finally, we'll generate a service where we'll add our business logic. And now we'll go ahead and take a look at the payments module. So in here, we're actually registering the payments controller and the payments service. The payments controller here, prefixed with payments, is simply an empty controller now. And same with the payments service here is an injectable so that we can actually inject it into our controller later on. Let's go ahead and build this out. To start, we want to be able to create new payments inside of this controller. So we'll go ahead and simply expose a new post route to do that. So let's go ahead and add the @post decorator and have a new create payment method here. And now we'll also extract the HTTP body on this request using the @body decorator. And we want to provide a type for this request. So inside of payments, I'll simply create a DTO folder where we can host our request interfaces, and I'll have a new create payment.request file. And this will simply define the shape of data for the new payment that we're creating. So we'll call this the create payment request. And this will have three properties. So we'll say if we're taking in a credit card, we'll accept the credit card number, a special CVC code, and finally the expiration will take in as a string. So we have the shape of the data now. We can reference it in the controller as the create payment request. Now inside of this method, we simply want to delegate this down into the actual service. So let's go ahead and first inject that, which we can do since we've marked the payment service with the injectable and we're part of the same module. We can simply inject it in our constructor. So we'll go ahead and inject this payment service. And now inside of our post route here, let's simply return this .paymentService.createPayment and pass in that underlying request. Okay, so now in the payment service, let's simply implement a very simple in-memory array of the payments we have so that we can later return them back to the item service over tRPC. So I'll simply mark a private read-only payments array, and now we want to define, well, a type for payment. Now we're going to do this later on when we actually define the payment schema inside of tRPC. So for now, let's just keep this typed as any so that we can continue. And later on, we will actually update the type here with our tRPC schema, because one of the great benefits of tRPC is it's a single source of truth for the types that can be shared amongst all of our applications, whether that's another backend service or a UI. So we have the payments declared. Let's go ahead and now create a create payment method that gets passed in the request type of create payment request. And now inside of here, we'll simply create a new payment object. And again, for now, we'll leave this as untyped. We'll simply spread all of the payment properties. And then I want to set an ID. So we'll set a payment ID equal to math.random. And we'll just take the toString substring and take from 2 to 15 to get a random ID. Finally, we'll push this onto the payments array and now return payment back to the caller. So now we have create payment implemented. We still have our development server here running in the background. Let's go over and head over to Postman now so we can actually send a request to create a new payment on this server. So we'll go ahead and launch a request at localhost 3001 because remember, we changed our port for payments in the main TS as port 3001. So we're targeting 3001, and now we want that /payments prefix that we added to our payments controller to target this controller. And in this post route, we know we need to update the payload that we're sending. So our create payment request will take that number property, and I'll simply provide stub values here to fill out the request. We have the code as well. And finally, the expiration date. So now we have a sample request. Let's go ahead and post it to the server, and we can see we have the 201 created response with the returned payment here. And importantly, we have this auto-generated ID that we can then reference later on, which is excellent. So now that we can create new payments, let's go ahead and update our items NestJS service to be able to accept requests to create a new item over HTTP. And this is going to use tRPC to then reference the payment that we associate with the request. So inside of items, let's go ahead and clean up by deleting the auto-generated app files to begin, just as we did before, and then clean up the app module as well. So let's go ahead and then use the Nest CLI by seeding into apps/items now. And we'll use it to generate the new items module. And we'll generate a controller and service for it as well. So now we've generated this, and our app module is updated as expected. We can see all three of these empty files, items controller here, and the items service. Let's go ahead and update the items controller to accept a new request to create an item. So we'll expose a new post route, and here we'll define async create item. Now we're marking this as asynchronous because eventually this is going to be an asynchronous operation when we're actually using tRPC to make a network request. And so now we want to go ahead and inject our item service into the constructor just as we've done. So go ahead and add the item service of type items service. And now in the create item, we need to go ahead and extract the body, which is going to be the request. And I want to define a DTO for this as well. So as we've done before, I'll create another DTO folder inside of items and define the create item request now. So we'll export class create item request. And so this create item request will have a few properties. We'll take in the name of the item as well as a description. We'll have a price number. And finally, we're going to have the payment ID of type string. And so this is going to be the identifier for the payment that we created in the payment service previously. So that'll be this ID here from the returned payment. And what we're going to do is actually look that up over tRPC inside of this route. So now in the items controller, we can type this as the create item request and return this item service create item and pass the request into it. So let's go ahead and finally implement this inside of the item service. So inside of the item service, let's go ahead and firstly declare a private read-only items array because we're going to maintain these items in memory just like we did for the payments. We can also define a specific type for items because we're not going to define the type as a tRPC schema. To do this, we'll simply create item.interface file. And let's go ahead and export interface item. Well, this interface can actually extend the existing create item request because it's going to have the same properties. However, we're just going to add on an additional ID of type string. So now in the item service, let's declare this items array of type item array. And now we can go ahead and create the async create item method. And here we're going to get past that create item request. So we'll go ahead and type this as the item type. We'll go ahead and spread all of the existing properties on the request. And then for the ID, we'll again just use math.random and use the toString and substring properties to just take a substring of it. Finally, we'll go ahead and push this .items and add the new item to the array. And we can return it back to the caller as well. So now we have the ability to actually create this new item over our items controller through HTTP. But now what we want to do inside of create item is actually reach out to our payment service over tRPC and fetch the payment profile associated with the payment ID passed in this create item request. In order to do this, we need to finally set up our tRPC connection from items to payments. So let's go ahead and get started with doing this next. So our first step is going to be to add the dependencies we need to actually support tRPC in our app. So to do this, let's cd into apps/payments, where we're going to set up our tRPC server. And since, again, we're using tRPC, we're going to add these dependencies just to this particular package that needs them. And then our npm workspace will add them. So let's go ahead and npm add. We're going to use NestJS tRPC, which is a great library to integrate tRPC into a Nest app with very little code and auto-generate our tRPC app router based off of the schemas we define. And we'll be able to reuse this on the client side, in this case, another NestJS app. We'll also go ahead and install Zod, which is used for the schema validation and building of the tRPC schema that we need. So let's go ahead and add these two dependencies. Now with this in place, the next thing I want to do is actually create our tRPC package that's going to host our tRPC schema. Now in tRPC, we can actually share common code that we want to share between multiple apps inside of the packages folder. And this is going to be like any other application that we already have with a separate package JSON, and then we can export common code from it. In this case, I want to generate our tRPC schema to this common package that we can then reuse from the client side, in this case, the item service, to consume that tRPC app router to ensure we only have one consistent set of types for tRPC that we can reuse on any client-side application. So let's go ahead and set this up. The first thing we'll do is create this tRPC folder inside of packages, and at the bare minimum, we'll simply just need a package JSON to register this within tRPC. So let's add a new package JSON. We'll provide a name of @repo/tRPC, which we're going to go ahead and reference later on inside of the consuming applications. We'll also go ahead and specify a starting version and set private to true. Now with this package JSON in place, let's also go ahead and cd into it. So go back to the root of the app and cd into packages tRPC. And now we want to go ahead and generate the dependencies that this will use. In this case, we're going to need to add super.json, which is a library that we're going to use to actually serialize data inside of our tRPC connection. So in this case, we'll go ahead and reinstall Zod, which is used to implement our schema inside of tRPC. And then we'll add tRPC/server, which is going to be used in our actual app router. Now, importantly, make sure we add -d to mark these as development dependencies, because in tRPC, well, in a shared package like this, we simply declare the dependencies that we're going to need from the consuming application as development dependencies. So now we have these dependencies in place. We're ready to actually generate this shared app router. So in tRPC, make sure we also create a source directory. And I'll also now create a routers folder. So this is where we'll actually host any of the tRPC shared routers that we want to expose. And so in our case, I'll create a separate directory here for the payment service, because we're going to create a new router for payments. So with this in place, we can now go back to the payment service, and let's go into the root app module, where we're going to go ahead and set up our tRPC server using that NestJS tRPC library. So in order to do this, we'll go ahead and import tRPC module from NestJS tRPC and call for root to initialize it. We'll pass in auto schema file. Now NestJS tRPC will actually automatically generate the TypeScript types associated with our tRPC app router based off of all of the routers and schemas we define in the service. And so this auto schema file is the global app router that can then be consumed from the client side. So let's go ahead and define this to be generated in our new tRPC package. So we'll simply go up 2 directories into packages, tRPC, source, routers, payments, to go ahead and generate that app router that can then be used as a source of truth for our tRPC types on both the server and client. And again, this is automatically generated based off of any of the routers we create now in the payments service using NestJS tRPC. And so with this in place, we should be able to now simply go back to the root, and if we rerun turbo dev, well, we can actually see in payments that we have the app router successfully generated at the path here that we've defined as server.ts. So now if we go look inside of our new package here, we now actually see this server.ts file, which is exporting an empty tRPC router, which we know, of course, defines all of the procedures and types on our tRPC server and client. So this is great. We now have this auto-generated app router that can be used on the server and client for an end-to-end type-safe solution. Let's go back to our package JSON for tRPC, and in here we'll go ahead and add an exports array, which is where we actually define what code is available for use on the client side. In our case, we want to define a new payments router export, and that will point to the source routers payments server.ts file that was just automatically generated. So our next step is to go back into our payment service and actually generate a schema for our tRPC router that we want to create. So what we'll do inside of payments folder, We can create a new folder to host our schema. And let's create the payment.schema file. And so we're going to go ahead and use that Zod schema validator library to build our tRPC schema. So we'll export const payment schema and set it equal to z from Zod.object and pass in the properties that make up this schema. So in our case, we know that's going to be the ID property on the payment we have. This is going to be the data that we're exporting to our clients over our procedures inside of the router. We then have the number to represent the credit card number, so we can use Zod.number, and this is going to register each property with the appropriate type. Finally, we have the code as well. And last but not least, the expiration, which is a z.string. So now we have the payment schema, which defines the shape of the payment. We can also export type payment, which can be used by our TypeScript code. And Zod has a helper function called z.infer, which will set equal to z.infer, which is a helper function to create a type based off of a Zod object. To do this, you simply pass in type of payment schema, and now we have both the type itself we can use in our code and the payment schema, which we'll use in our router itself. And this, again, is going to be the source of truth for the actual shape of the data on both the server and client. So any changes we make to this payment schema will be reflected all over our code at once. So with this in place, we can now firstly go back to the payment service, and let's update our payments array to now reference our new payment type that we just generated. And we can update the payment object that we're creating inside of createPayment. So this is another nice benefit, is it generates the types for us. We don't have to recreate them each time we need them. Last but not least, we're ready to create our first router, which is the entry point into traffic on our tRPC server, just like a controller is for a NestJS HTTP route over REST. So inside of payments, let's create the new payments.router.ts file. And this is going to make heavy use of pre-built decorators from NestJS tRPC, which registers the router for discovery to be generated inside of our auto schema file. To do this, we simply use the @router decorator from NestJS tRPC, and we can pass in an alias for it to give it a specific name. I'll call it payments, and then we'll export class payments router. Now we'll define the procedures available within the router. Let's also firstly inject the payment service. So we have the payment service available. Let's add our first procedure using @query from NestJS tRPC. And here we define the input and output to this procedure. So in this case, the input, well, if we're querying for a payment object, this is simply going to be by the ID of the payment itself. So we'll define this using Zod again as a object that comes into the server with a single property of ID of type string. So that's going to be the ID of the payment we're looking up. And for the output, tRPC defines output validation as well. We'll provide the full payment schema that we already generated using Zod. And so now we can create get payment. And to extract the input from the query procedure, we can use the @input decorator from NestJS tRPC and extract individual properties from inside of the object with the string here. So this will be ID of type string. And finally return this .payment service .get payment by ID, and let's pass in that ID. So the payments router is now available. Make sure we also go back into the payments service, and let's quickly implement the get payment by ID method that gets passed in that ID of type string. And we'll simply check to see if we have this payment by checking this .payments array using .find and looking on an individual payment, comparing the .id to the ID that gets passed in for the lookup. And if we didn't find the payment, we can apply some quick validation and throw a not found exception saying payment not found. Otherwise, return the payment back to the client so we can use it. So last but not least, make sure that you've actually added the new payments router to the payments module inside of the providers array, because it's simply another injectable class inside of our Nest app that has access to the dependency injection. So we'll add payments router. And with this one change in place, our payments app router should now automatically be generated and updated thanks to the NestJS tRPC decorator that we added. And we can see that has been done exactly here back inside of the server.ts file for payments. We see the app router has been updated with this new payments router. Inside we have the get payment procedure with the shape of the data being sent in and returned back. So this is great. Our app router is updated. It is available inside of our Nest tRPC server in payments. And now finally we can reference this inside of our item service client for an end-to-end type-safe solution. So we're ready to implement the client-side step for our tRPC microservices. To do this, we now need to go into the client, so we know that's the item service itself, and add some dependencies. So we'll go ahead and install at tRPC/client, and also make sure you install super.json. So tRPC client is the client we're going to use to connect to our tRPC server from our Node app, in this case NestJS service. And super.json is a transformer that we can use to transform the incoming data to actual JSON that our app can use. Now, one additional dependency we'll add manually to the items package JSON, well, it's going to be, we need to actually bring in the tRPC app router for payments that we're exporting from our common tRPC package. And that's going to give us the end-to-end type safety. To do this, let's go ahead and update our dependencies object. Well, to reference a turborepo package, we'll just use the name inside of its package JSON. So here that'll be add repo/tRPC. And let's go ahead and set this to workspace : star, which is special syntax to tell pnpm that this is a workspace dependency and should be installed and linked locally. So now we can rerun pnpm install from the root, and we can see it has succeeded. We'll also just restart our development server. Now with the dependencies we need in place, the next step is to go ahead and create a new injectable class inside of items that can actually create the underlying tRPC client that our item service or any other code can use to reach out to the tRPC server inside of payments. So to do this, I'll create a new directory inside of items and call this clients. So for each application you had, we could have a separate client to each tRPC server inside of your microservices architecture. So inside of here, we'll create the new payments.client.ts. And so this is going to be the tRPC client that we'll use. So we'll export const create payments client. This will be a inline function that gets passed in the URL type string, which is the endpoint of the tRPC server that we're going to be connecting to. And so what we'll do is we'll return a call to create tRPC proxy client from tRPC/client, which is going to establish the connection to the tRPC server. But first, we actually give it the type information here, which is going to be the app router type, which provides end-to-end type safety and type information to this client object. Well, in this case, we know we can import our app router that's generated from our tRPC server using our at repo/tRPC/payments router import. And we can pass that app router type directly into create tRPC client to give it the type information of the server, which is going to provide that type safety. And then we provide an options object where we set the links property to an array of links, which is going to actually establish the HTTP connection using the HTTP batch link, because of course we know tRPC simply operates over HTTP, so we need this link to actually establish the connection. And in here we actually provide the underlying URL to the tRPC server. So now we have a completed function to create this tRPC client. However, you'll notice we actually have a type error about this import. So in order to resolve this, we need to go back to our tsconfig JSON for this item service. So inside of the tsconfig, make sure we update our module here to use node next. And importantly, we also then have to set module resolution to type node next as well. With this change in place, we can now go back to the payments client and see that it no longer is throwing any sort of errors, which is great because it means we can now use it inside of our actual application. Now, importantly, you might see an error here about a type issue around our app router import. The reason why we're seeing this is due to varying versions of TypeScript inside of our npm workspace. If we go ahead and look for TypeScript inside of our workspace, we can see we have it set at various versions. I want to go ahead and standardize this version. So let's go ahead and update our package JSON inside of items and payments to use the version of 5.8.2. So we'll all be on the same version. Additionally, I want to go to the root package JSON and add a new key for npm. And then we want to add an overrides to specifically specify that TypeScript should always be used at version 5.8.2. And this is to ensure that our dependencies also use the same version and prevent having this issue with our tRPC library. So make sure we go ahead and also remove our node modules folder. Finally, we also need to make sure we actually remove our npm-lock.yaml. Since we've updated our overrides, we want to regenerate this file. So now in our root, we'll go ahead and reinstall our dependencies to get the latest with our pinned TypeScript version. And now after our dependencies are available, we should be able to rerun turbo build command to see that our application is now building successfully, and we no longer have any issues with this type inside of our payments client, which is excellent. So let's go ahead and continue on with actually using it. The last thing I'll do is also define an interface to represent all of the available clients that we have in our application. So let's create a clients.interface.ts file. And this is going to represent the actual injectable type that we can use later on inside of our item service or anywhere else in the code. So we'll export interface clients. And inside of this object, we'll have a property for each of our client objects. So we'll have the payments client, and this will use return type of create tRPC. So the same function that we just used to create the client, and then pass in the actual payments router here. And we'll define this as payments router in case we have multiple app routers here. So then we can import app router as payments router from the same import, so at repo tRPC/payments router. So now the client's interface is ready. We'll export const clients and set it equal to the client string in uppercase. And this is because this is going to be the injection token we use to actually inject our generated clients later on. So with this in place, we can now set that up. Now the last step is to create the actual client's module, which is going to actually make the client's object available to our application as an injectable dependency, because we only want to create this client connection once when our application starts up and reuse it throughout the app. And that's exactly what a NestJS injectable dependency allows us to do. So we'll export class clients module and decorate it with @module from NestJS common. And so this is going to have a single provider in the providers array, a custom provider that we'll set up now. So to do this, we have the provide property, which is the injection token, that the dependency is identified as and used later on to inject it inside of our constructors. So that's going to be the client string that we just generated. And to make this a bit cleaner, we can actually move the client's injection token out of the client's interface. And let's create a new clients.constants file just to make this a bit cleaner, and then import the client's injection token from the constants file instead. And to now actually set up this client object, we'll use useFactory, which allows us to actually inject dependencies directly inside of here when creating the provider. In our case, we need to make use of a new dependency, the NestJS config dependency, which uses .env to read in environment variables through a .m file at runtime. In our case, we want to define a .m file to define the address of our tRPC server, which we know changes based on where we're running the app. So to do this, let's cd into item service and make sure you npm add at nestjs/config. So this will give us access to the config module that we'll set up in our root module. So go back to the app.module for items, and let's go ahead and set up the config module. So we import config module from at nestjs/config. To initialize it, we'll call for root, and that will read in any environment variables defined at a .env in the application root using .env library. We'll also set isGlobal to true, so it's available in all parts of our application. And lastly, we'll actually create this .m file so we can define our environment variables that we want to inject to the application. In our case, we only need to define this payments URL, which is where our tRPC server is actually listening on. Well, in our case, that's simply going to be HTTP localhost, which is where our application is actually running, and the port of the tRPC server. In this case, it's payments. We know the port is over 3001. Now, by default, NestJS tRPC exposes the tRPC server at /tRPC. So this will be the final endpoint to actually connect to our payments tRPC service. Let's go back into the clients module, and inside of the useFactory, we can now actually inject the config service directly as a parameter into this callback function. So I'll go ahead and also import the config service from at nestjs/config. And so in the useFactory, we can actually define the return type of here, which we know is the client's object interface that we defined. And now we'll go ahead and return that. So inside of this object, we have the payments client property. Well, to create this, we simply use the create payments client function that we created earlier. And all we have to do is now pass in the URL. To do this, we can now use the config service, which allows us to pull off environment variables using get or throw, and we'll pull off the payments URL environment variable. Finally, make sure we also add the inject property and explicitly inject the config service so it's available inside of this useFactory. So now that we actually have our payments client available and ready to use, let's go back inside of the item service where we want to actually inject it and make it available. To do this, we'll add our constructor and use the @inject decorator from Nest Common, and then provide the same client's injection token that we used inside of the client's module. So that's how we actually reference this provider here that we provided. We simply provide it into @inject, and we'll set this type equal to private read-only clients of type clients, and we can use our client's interface that we've defined as well. Now, critically, in order to actually make this injection possible, we need to go back to the items module and make sure we explicitly now import the clients module, since that's where we actually declare this provider and we'll make it available inside of this items module. Additionally, we have to go back to the clients module itself, because right now we're providing the client's provider, but we're not exporting it from this module so that it's available in other modules. To do this, simply add our exports array and provide the client's type. Now we can see that our application is running successfully, and we have this client available. We can finally use it to make a request to our server to fetch our payment profile associated with this item that we're trying to create. So let's go ahead and do just that. I'll create a new const payment and set it equal to, well, now we can use this dot clients and access our payments client, where we have the payments object itself coming in from our tRPC router. So this is the tRPC router object itself, and we can see we actually now have the procedures defined on that router. In this case, that get payment procedure we defined earlier. So this is showing this true power of this solution as a transport layer in our microservices. We have this end-to-end type safety around the actual functions we can call over network, in this case get payment, and this will of course update in real time whenever we make changes to that schema, thanks to NestJS tRPC and this great development experience. And then finally we'll call .query, where we'll actually expect the input, where we have the ID property, which is going to set equal to request.payment ID to fetch the appropriate payment. So now we're successfully fetching the payment associated with this item using tRPC over HTTP to reach our payments microservice. So at this point, we could do some validation with this payment. We could use it to actually bill some sort of third party like Stripe or something like this. So I'll just leave a comment here saying use the payment somehow. In our case, we'll simply log out the payment to show that we're actually successfully retrieving it from the payments microservice, and our tRPC connection is working successfully. So let's go ahead and finally open up Postman to test this out. So now inside of Postman, I'll go ahead and create my payment once again. So I'll go ahead and then copy the payment ID associated with this. And let's go ahead and create another request to create an item now with this payment ID. So I'll go ahead and add a new tab here where we now reach out to localhost 3000/items. We know this is so that we can target our items controller and the create item route. Then we'll go ahead and update our body. So recall that our create item request needs the name, description, price, and payment ID. So I'll go ahead and fill out this request body with all of these details. So I've gone ahead and now filled out the request to create this item, and I've copied over the payment ID from the previous request so that we're associating the correct one, and our tRPC lookup will succeed. So now if we send this request off to the server, we can see it was successfully created. And now if we go ahead and check back in the terminal to see our logs for the item service, we can successfully see our log statement here where we're logging out the payment that we've retrieved over the network from the payment service, which is excellent. It means our tRPC microservices are working successfully, and we've shown how we can set up this great end-to-end type safety inside of a NestJS microservices environment, as well as the front end. So thank you so much for watching. I hope you learned a lot in this lecture, and I'll see you in the next one.